Hi and welcome back. I hope you are doing good today. You see this water amazingly and lovingly flowing out here, but this is also a concern. This beautiful water, what we live with, is a life. We all have been seeing these things for a long time out here that we have various different states not getting water, scarcity, and so on. Now, one of the very major way we lose water or waste water is by like overflowing tanks, keeping the taps turned on unknowingly or knowingly, and so on. We usually turn on the motors and then we forget to turn it off. That keeps going and going and flowing. That has happened with multiple of you all. Even with me, it has happened multiple times. I turned on the motor and then kept it on for a longer time and forgot to turn it off, and then I saw that thousands of liters of water has gone until I turned it off. So there are various different solutions present in the market, and various different things. Some are wired, some are wireless, some are cheap, some are expensive, and so on. So today, we thought like let's make our own and then make it various different specific requirements what we have at this. So with this idea, we are presenting you with H2OSense. So this is the name which we gave to this thing. Let's see what do we expect from this, or the futures we are expecting to have from this, and so on. So this is how the quick model looks like for us for now. This is the unit which is going to be just installed into the cap of a uh, overhead tank. So you have this uh, nut kind of a thing. You can just bolt kind of a thing. Just go ahead and then uh, rotate it and tidy it off. As simple as that. If you want to make it a compact in size, have it wireless, self-powered, easy to install, and additionally, we want to have these features into it, like it says water level. We also want to have battery monitoring. We want to have it modular and easy in concept, so that like various different units of it just replace as it is wireless too. We also want the water to be the sensor to be corrosion and humidity proof, because we don't want it to get corrupted with any sort of humidity occurring inside the water tank and so on. So moreover, like a waterproof sensor sensor, and we wanted to have it Wi-Fi mesh capability with sub modules and so on. And then we also want to have an OTA with this. It should be consuming lot less power because we wanted to run it for longer, and it also should be a self-sufficient, that is solar powered. It should also have functionality with data logging, configurable deep sleep intervals. Like for example, if you want to have a 10 minutes interval or 5 minutes interval or 1 minute interval based on the various different requirements what we have. And we can also we want to have it configurable with alerts and notification and dashboard and analytics. So these are the total things which we are expecting from this H2O sense, what we have designed and thought for. So let's start uh, designing this and see how it works to be, and see like what are the different things you can implement into it. So let's get started with our go with this and see how can we proceed this further. So here's a quick final design what we have done here. So this is the box what we have with this, and we're going to have the electronics into it, and there is a 0.5 mm nets what we have given here, and this is the space for the solar wire to come out, and this is the M30 net and this thing screw what we'll have it here. And this is going to have a sensor hose within it, SR04M sensor what we have with this going to be within that. And coming back here, we have this quick little additional piece what we have just to add a touch of different colors to it. And this is the solar mount what we have at this. This is going to just uh, swivel, or you can say like turn this side and that side based on that. And there's a quick cab have it. So we'll just 3D print all of these things. Everything is all done here, so I just had to use this 10k resistors. So this is for voltage divider, and then I have this DIP switch with me this side for various different things. And mm, yeah, pretty good with this. We have 400 milliamps battery just down there, and TP4056, and these are for the solar wires. So let's see, according to our calculation, we had approximately 12 days of not 12, 6 days of power store. So we are here in the coding part. Let's see what we have here. So this is a quick coding that we have done for this. This is going to be for the sensor, which is going to be mounted on the scanner, sorry, on the drum, or you can say on the water container, whichever you have it. And quick thing here, I'm using an ESP now here with an Wi-Fi.h, and then I'm going to have a voltage divider in A0 analog pin, and I have two values R1 and R2, each one having like 10 kilo ohms. Max voltage of the lithium-ion battery is 4.1, minimum voltage 2.8 to be safe level, and so on. And this is a quick calibration factor which I set to 1.52, and this is the MAC address of my receiver of my master board, which we're going to receive the values from this ESP now. So, and this is a quick message structure. What we have with this distance, the current in percentage, and the voltage, and quick delay between each readings, 2 seconds. Trigger pin to D7 and echo pin to D6, and duration and distance in centimeters. And I have made this D5 as an output here. There's a reason for this, like why I've made this out here, and this is made specifically because we want to have the sensor which is connected to my uh, board, and I wanted to have it for longer time, right? Like when we go ahead and then let the ESP8266 sleep in a deep sleep mode, if we directly connect or make the power as a direct to the sensors, that will keep consuming that electricity or current. They do not want to have that thing, so I made deep as a ground so that like the current always go only when it is inactive. The voltage pin is an input and a co-pin input, and then so on, quickly initializing the ESP now all the way here. And if it is successful, the packets are successful, it prints delivery success or delivery failed. And here we go here with the timer delay, and this is the quick I made this low because I want to have a ground for this. And the other pin of the sensor, that is SR04M, is connected to the uh, 3.3 volts, and it works perfectly fine with that. And quick ultrasonic part of the code here, and I'm getting the raw value, voltage, battery percentage calculations, and assigning the data to each of those structures, and then printing both of this and getting it done. So you see this, like I have here the values coming in, and you see this, like I have given here 60 seconds delay. That is not delay, I'm like 60 seconds deep sleep. So it will send this value to the respective board what we have set here, and is going to go ahead for deep sleep for 60 seconds. So that is every 1 minute it will send one data and then go back to the sleep. So as far as my current consumption is 0.08 amps, that is 80 milliamps to 90 milliamps is the current consumption to the peak here. And you see this, like every second I'm getting a values here. 28 or 10, 28 I got these three values, and then 22, 9, 28 second I got, and they're very accurately like coming every second. Slightly 1 sec per 1 millisecond difference. 528 again I got a value. 628 again I got a value. 728 again I got value. And just now I got one more value here. So I'm getting the values from the given board. So let us just show you the quick setup, like how am I getting all these values here. So let's see this here. Right, so here's the quick setup, and this is the one which is sending the data to my the data what you see on the screen out here coming every second. So it looks like a camera, pretty much decent and clean here. This is where I can just all this. I'll show this later. And from the side, it looks like this. And I have all the such as what I have here. It's going to let me do it more about this later. So this is the one, and I'm receiving the values with this. So I have this one, a ESP8266. So they're sending the data, and I'm receiving this with this one, and this connected to the laptop, and I'm getting the value with this. It works perfectly fine. And let's see, uh, proceed further. What I'm going to do is like get this as a one in between, and then we also have this coming in, another module what we'll have it, and module with a quick ESP01, And then go ahead with this. We will come with this new model out there. So stay tuned. If you love the video, then please go ahead and then like the video out there, and then share with the friends and so on. If you've not subscribed to the channel, then please do that. And let us know if you're waiting for the other part where we can just have all of these different units, totally connect them together to see the whole system working. So we're just coming into part. We've already started working on this design. Let's do this thing. There's all the set here. So let's have a look.